Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. These lectures cover geometric and Poisson distributions. Our main objective is to learn how to find the probabilities using the geometric distribution and also the Poisson distribution. So we start with the geometric distribution. Here we say a discrete probability distribution. So again, a geometric distribution is a discrete probability distribution, which means the random variable is based on counting. Also, it satisfies the following conditions. A try is repeated until a success occurs. Also, the repeated tries are independent of each other. And also, the probability of success P is constant for each try. And then the probability that the first success will occur on a try X is P at S equal to P times Q to the power S minus 1, where Q will be the probability of failure, so it will be 1 minus P, probability of success. So let's see an example. Yes, they say from experience, you know that the probability that you will make a sale on any given telephone call is 0.23. So that will be our probability of success, or P. Find the probability that your first sale on any given day will occur on your fourth or fifth sales call. So this means our X value will be either 4 or 5. So we need to find the probability when X is 4, and also the probability that when X is 5. And since this is fourth or fifth, we add both two probabilities together. So the solution, we say again, we're looking for probability that the cell on fourth or fifth call. So it will be probability of 4 plus probability of 5. Based on the question, the P is given to us to be 0.23. So Q will be 0.77. Because 1 minus 0.23 will give us 0.77. And also the X is 4 and also 5. That's the fourth and fifth sales call. So we look for the probability of 4, which will be 0.23 times 0.77 to the power 4 minus 1, because the formula is P times Q to the power S minus 1. Then we also find the probability at 5, the fifth sales call, is to be 0.23 times 0.77 to the power 5 minus 1. And that gives us 0.080852. Then we need to find the probability of sale on fourth or fifth. As we went through previous probabilities, all means plus. So we add probability of 4 plus probability of 5. So our final solution will be 0.186. Now let's see the Poisson distribution conditions. So again, Poisson distribution is a discrete probability distribution. Also, it satisfies the following condition. The experiment consists of counting the number of times an event S occurs in a given interval. Also, the interval can be an interval of time, area, or volume. Also, the probability of the event occurring is the same for each interval. Then the number of occurrences in one interval is independent of the number of occurrences in other intervals. The conditions also is, one of the conditions is the probability of the event occurring is the same for each interval. Same concept as, again, geometric distribution. The probability of the items occurring, the tries, they are independent, and also they are the same for any number of tries. In Poisson, we normally deal with a period, an interval. So here we say the probability of event occurring is the same for each interval. As in geometry, we say the probability of each tries is the same. Now, to find the probability of exactly S occurrences in an interval, the formula will be probability of x equal to the mean to the power x, e to the power negative mean divided by x factorial. Again, we know e is an exponential constant value, which is 2.71818. And the mean will be the mean number of occurrences, or the mu. So let's see an example. Here they give us the mean number of an accident per month at a certain intersection is 3. So this means the mu is given to us, which is the mean. Now, what is the probability that in any given month, so our interval is monthly, 4 accidents will occur at this intersection? So this means we know the value of the x because we said 4 accidents will occur at this intersection within the period, the interval, which is months per month. Now, we know the mean is given to us to be 3 because the question said the mean number of accidents per month at a certain intersection is 3. So the mean is 3. I know the S value. So if that's the case, we can find the probability that 4 accidents may occur in a given month. So that will be the mean to the power x, so 3 to the power 4, e to the power negative mean, so it will be 2.71828 to the power negative 3, divided by x factorial, which will be 4 factorial. So again, using your calculators, our answer will be 0.168. Again, we can see the formula in our previous slide. To find the Poisson distribution, probability of x will be the mean to the power x times e to the power negative mean divided by x factorial. And that's what we have. The mean again is 3. The x value for accidents, that's our main random variable. And in this case is 4. So we have 3 to the power 4, e to the power negative mean, which will be 2.71828 to the power negative 3 divided by 4 factorial. So in summary, again, these lectures, we learn how to find the probability of geometric distribution and also Poisson distribution. We saw their conditions and also the formulas to use. So again, see you in the next lectures, and thank you for your time.